we are going to start unit 3rd, centroid and center of gravity. Centroid is a geometrical center of a figure, that is, it is the center of any specific area. Center of gravity. Center of gravity, it is the center of mass or gravitational center of a body. So the main difference in centroid and center of gravity is that centroid is only related to two-dimensional shapes or areas, while center of gravity, this CG, is related to volumes and for bodies, that is three-dimensional. So the thickness will be there. It means there will be a material also. So the density of a material produce weight. And center of gravity comes into play. So the main difference in the centroid and center of gravity is that centroid is only for the two-dimensional shapes and figures, while center of gravity is for three-dimensional bodies and for volumes. Now, centroid suppose there is a shape of area capital A, and this is the centroid of this area. We assume the coordinates of this point are x bar and y bar. Generally, we denote the centroid by the x bar and y bar. Now, to determine this distance x bar and y bar, we require reference lines from where this distance can be measured. This x bar is measured from the y-axis, while this y bar is measured from the x-axis. So remember always, x bar is measured from the y-axis and y bar is measured from the x-axis. So these are the reference lines. So to show the distance of any point, we require two reference lines, one along x-axis and other one is along y-axis, and these centroid coordinates are x bar and y bar. Now if this area A is divided into different small areas like this. Suppose this is A1, this is A2, this is A3, this is A4, and this is A5, and this is A6, A7, and this is the reference line, y-axis, and this is the reference line along x-axis. So this is the centroid of A1, centroid of A2, centroid of A3, centroid of A4, A5, and so on. And the coordinates of A1 is x1 bar 1, y1, and for A2, x2, y2, and A3, x3, y3, and so on. Now we take the movement of areas about x-axis and then y-axis. So first of all, take the movement about x-axis. So movement about x-axis. The total area is A, and the distance of A from x-axis is y bar. This will be equal to A1, y1, sum of all areas, sum of all moments of all areas, A2y2 plus A3y3, and so on. Or A into y bar is equal to summation of ay, or this y bar can be calculated by summation ay upon capital A. This can be written as y bar is equal to summation ay upon summation A, because this summation A is equal to capital A. Capital A is the total area, and this total area is divided in small areas A1, A2, A3, A4, and so on. So summation A can be related or can be said to equal to capital A. So y bar is equal to summation ay plus divide by summation A. Similarly, movement about y-axis. A into x bar is equal to a1 x1 plus a2 x2 plus a3 x3 and so on. So similarly, x bar is equal to summation ax upon summation a. So from this we can say that x bar is equal to summation ax upon summation a, and y bar is equal to summation ay upon summation a. Similarly, so these are the centroid. Now the centroids of particular shapes. So first of all, for rectangle, suppose this side is B and this side is A. So the area is B into A, and centroid x bar is by2 and y bar is a/2. If the reference axes are passing through these adjacent sides, this is x-axis and this is y-axis. So this is, suppose this is centroid. So this distance is by2 and this distance is a/2. So this is x bar along x-axis and this is y bar along y-axis. If the reference line is passing through the centroid, if the reference line are passing through the centroid, then x bar is equal to 0 and y bar is equal to 0, because now the reference lines, these are the reference lines and this is the centroid. So these are the reference lines passing through the centroid x bar and y bar. So distance from the reference line is x bar and y bar, both are 0 at this point, and these are the reference lines. From these reference lines, the distance x bar and y bar is equal to 0. Now for a triangle. So in triangle, in a right angle triangle, centroid this is the centroid, and from if this is base B and this is height H, then this is x bar is equal to b by 3, and this is y bar is equal to h by 3. So x bar is b by 3 and y bar is h by 3. So these distances are from the reference lines which are making right angle to each other. Reference lines are making right angle to each other. So from the line, right angle line, x bar is b by 3 and y bar is h by 3. In other case, if the reference line is passing through this point, then the distance will be measured from this side, and from this side it will be x bar is equal to 2 by 3 of b. From the small angle side it will be 2 by 3 of b, but we are measuring the distance from this side, right angle side, so it is x bar is equal to b by 3 for a triangle. Now for a triangle like this, this is a triangle made by two right angle triangles. We can draw a line of symmetry from this. For this triangle, there is a line of symmetry. So in this figure, centroid will lie on the line of symmetry. Line of symmetry on this line. This is a line of symmetry. Line of symmetry for this triangle. So centroid always lie in symmetric figures. Centroid always lie on the line of symmetry. So this is line of symmetry. So for this figure, centroid will lie on this line of symmetry. So in this figure, x bar is equal to 0 because this is the reference line and centroid is lying over this. Second reference line is taken here, and the total height of the triangle is h, and the centroid will lie here. From this is y bar is equal to h by 3. From this line, the centroid will be at h by 3. Now for circle, for a circle, center of the circle is always, suppose this is a circle, the radius of the circle is r, and this is the centroid, center of the circle. This center of the circle is always called as centroid. So here, if the reference lines are taken as these lines, then the centroid x bar is equal to 0, y bar is equal to 0. If the reference lines are taken as these lines, if the circle is like this, the reference line one is here and other one is here, in same circle with radius r, then this is the centroid x bar and y bar. So here x bar will be equal to r and y bar is equal to r, because now the reference lines are these and this is the centroid. This is r. These are the, this is x bar and this is y bar. Now the reference lines are these lines. So distance of centroid is always measured from the reference line. So reference line is very important. So reference line is very important. If you forgot reference line, then you can't measure the distance of centroid. So first of all, you have to consider the reference lines. The reference lines are very important in measuring the centroidal distance. Now, semicircle. In semicircle, this is a semicircle. And from this semicircle, a line of symmetry can be drawn like this. From this line, this figure is symmetric. So this is line of symmetry. So we know that centroid lies over the line of symmetry. So in this figure, the centroid will be on this line of symmetry. And the second is this. So this is the diametral axis of the semicircle and radius is r. So now this distance is 4r by 3 pi. This is y bar. So in this figure, x bar is 0 and y bar is 4r by 3 pi. Okay. Now, if the figure is like this, then the centroid is this. This is the line of symmetry. So in this case, x bar is 0 and y bar is minus 4r by 3 pi. In this case, so y bar is 4r by 3 pi, but with minus sign, because it is taken below the reference line, negative side of the reference line. If now the figure is changed like this, now the line of symmetry is this, and the centroid will lie here. So In this case, now in this case, x bar is 4r by 3 pi and y bar is 0. X bar is 4r by 3 pi and y bar is 0 because this is the line of symmetry and this is the other line which is passing through the centroid, and this is the reference line. This is the reference line taken along the y-axis. So from y-axis, x bar will be the distance, and from x-axis, y bar will be the distance. So this is the centroid. This one is the centroid. So this is from x-axis, 0 is the distance, so y bar is 0. And this is from y-axis, x bar is 4r by 3. Now, if the orientation of the figure is changed like this, then this is the line of symmetry, and from this line of symmetry, y bar is equal to 0, and this is the reference line. So from this is x bar, and this will be equal to minus 4r by 3 pi. So you have to remember that in semicircle, in a circle, there is no problem of the orientation, because in any orientation it seems like the same figure. So x bar is equal to 0, y bar is equal to 0, or if the reference lines are shifted, then x bar is equal to r and y bar is equal to r. But in case of the semicircle, when the figure on orientation is changed like this, if this figure is shown like this, then the x bar and y bar are both are changed to each other. Here x bar is equal to 0, here y bar is equal to 0, here y bar is equal to 4r by 3 pi, here x bar is equal to 4r by 3 pi. So you have to remember that the 4r by 3 pi distance is from the section line by which the semicircle is cut down to make it from the circle. Understand? It is clear? Is it clear or not? We have to remember that in a semicircle, 0 is the distance, 0 is